data is unique for every country, right? So how do you plan to do that? Because I know that UAE has a different reference datum. So is it easy to get a unified reference datum?
That's a very good question. So indeed, it's true. Every country has a different datum, a vertical datum system. Every county sometimes has a different vertical datum system. We are actually looking at a single unified datum which is provided by the geo of the planet. That's the one which is actually we're referring all of our information to. So a datum which is called WGS 84. And that's the one that we believe is the one that, just choose one. I want to choose the planet. I don't want to choose the country.
I know. Yeah, because UAE is gradually changing to WGS 84 right now. But not all the Middle East countries. They are still using other reference datum. So yeah, this would be different. And I have a question for you too. So when you said that you are flooding the whole earth by water, so what about the temperature? Because we know that if you go to the Arctic, the temperature will be different than when you go to the mid latitude. It will be like is it going to be like a uniform one or?
Well, in the model that we built, this was taking the topographic and the bathymetric data. So we have the map of the surface of the land above sea level and below sea level. And the proposition was simply, can you use this to demonstrate what's happening? I mean, so of course on something the size of the moon, if you made it 2 meters by 3 meters, it would be smoother than a billiard ball. It would be absolutely flat at that scale. So we have to exaggerate the Z so you can see the height. We exaggerated it 100 times. And then you can see something. Because if you can't see it, it's not very exciting. Once you can see it, you can start to bring in the water. And then you can use it in all sorts of ways. So on the 2 by 3 meter model, you can project onto it. So you can project, for example, Gulf streams. You can project storms happening in real time. You can project changes to do with temperature or salinity or other factors. So really, cartography is at the core of what we're doing. So to me, cartography is the realist representation. People used to think photographs were real. I mean, now we know photographs can be an image or they can be an object, but they knew that in the 1850s as well. So this isn't new technology. This is technology that's been around for a while. So the real issue is how can we build these dynamic models in a way like Bruce was showing beautifully with words. So I think this great way that beautifully displayed words lead your mind. That my dominating image of this morning is Bruce with his mouth open, because this very cheap trick that worked on everybody is you take a pose, then you change one part, and everyone pays attention to that part. And in a way, that's what we're trying to do. We're trying to say, so could we build a model that had ice? Yes. Could we build a model that did temperature? Yes. I'm not sure I want to do that at the size of a football pitch, but on a smaller level you could do it. And I think the more ways you can show and focus on what you want people to focus on, that's the design side, then I think we can really bring about a massive change. And, I would love to see the model of the world flooding and projected, because everyone who sees it just gets amazingly excited. And it's one of the things that can capture the public imagination. And I think that's a big part of what Factum is involved in.
A question, so, I think this is super fascinating, and I've looked at the session with water, but I really don't understand it. So, how, and I could be off topic, but I'm just going to ask the question. So, recently it rained here, so this is my first time here in Dubai, and it rained. And I woke up one morning and said, oh, it's just a rainy day. But it was flooding here, and it caused all sorts of chaos, like kind of like a snow day that we have in Canada. And I'm just curious how your technology, would help here in the Middle East. So now you've got, water's not absorbed, it runs off, it's fresh water, et cetera, et cetera, et cetera. I mean, how does that, the IoT and AI and that data sort of help here in places that have perhaps water scarcity, but there's a gift of a big dump? Does that deal with that, or is it only just the oceans?
No, it deals with water everywhere, not only in the oceans, but also inland water. So our technology is looking at all sorts of forms of water. We are able to look at precipitation rates. With a single device, we're looking at precipitation rate, water levels, tidal changes, agitation, waves in the ocean, snowpack, etc. And the principle is essentially start collecting data. So you have to start by putting this technology out, start collecting data, look at the patterns, understand how the behaviors are unfolding, and then take it from there. What you do after that, how to alert the population, all this now. What I would say is that you cannot alert the population. In the next 3 days from now, everybody has to go home and go to the high floor. You forget about that. That doesn't work. We're taking a measure which is looking at from the point of view of nowcast. So nowcast is what is occurring now. So if you have a problem which is coming to you, and you're verifying that that problem is occurring, as you see it moving towards you, you know the problem is going to hit you. So you are able to provide an early warning to the population, corporations, whoever needs to take action and protect themselves, people, inventory, money, assets, buildings, etc., etc. So my recommendation for all the customers that we talk to is let's start collecting data, because there is not enough data.
Any other questions?
Thank you. I was kind about, I was listening to you, and at first I thought that you could use GPS data to detect the water height and the changes in it on a very high frequency. Is that working or not?
No, that's not the principle that we're using. So it's called reflectometry.
Right.
So what we do is essentially we pick up, sorry for the technical discussion, but you pick up a signal which is coming to the ground and bounces and is picked up by a sensor. But at the same time, we're also picking up the signal directly. So we're comparing both, and then it contains certain features that is actually unfolding into the data types that we're collecting.
Okay, so you're not analyzing the GPS data going back and forth, you're catching it in the middle, but going both ways and analyzing that.
It really is the harmonics of waste noise from mobile phones. So when I first met Javier, I had exactly the same question. So Javier got rather fed up with me after a while, because I was constantly saying, yeah, but how are you doing it? And he said, I can't tell you. And I said, well, if you don't tell me, I don't believe you're really doing it. So then we put the sensor on the front of the building in Venice, and we started monitoring it real time to see how close it was to the published data or the expected data that was coming out of the city of Venice. We spent a lot of money monitoring their water. And actually, we were completely parallel, except that it deviated. And then ours was, or Javier's, the data was right, and the other data wasn't. So it is really capturing, as the little image did, the reflection of water bouncing, the reflection of a mobile phone signal bouncing off the surface of water. And to me, that's a work of art.
Thank you.
Rather than
Thank you. Thank you very much for this inspiring talk. Are you considering water vapor? Because water vapor is one main water source which is really important for plant productivity and forest conservation. Are you considering that?
No, we're looking at many forms of water, but not water vapor. At the end of the day, the intent with this platform that we're building should be that all components of water, or the lack of it, should be included inside it. So we're looking at all the things that I've talked, water vapor, and we're putting together also things like water quality, contamination levels, looking at social media. I mean, how many people take photos of water in action? A lot. How many people take photos of water when they're having fun on vacation? A lot. So let's understand water properly. We understand better the outer space than our own planet. In our own planet is where we live. I'm not going to go to Mars. I'm not signing up for this. I want to live in this planet. I want to leave a legacy to my children and my generations to come. And I want to make sure that they know how to live with water. And the only way to live with water is understanding it for real, not just small little data points here and there.
But I think it's also worth adding that once the sensors are positioned, they can be operated from very small solar panels, and they can go anywhere. And they can be added to. So over time, if there was a new sensor monitoring lichen growth on lighthouses or monitoring humidity in the air, but that's starting to be more like a traditional weather station. So we keep adding more and more types of monitoring. Here we're focused on saying, can you take a waste product and tell us about the surface of the water for free? That's the fundamental thing. You're not having to generate the source. Normally you do.
Thank you.
Thank you very much.